Hey class, Absolute 5 here, and today we're going to talk about writing fractions as decimals. Writing fractions as decimals. So, how do we do that? To write a fraction as a decimal, you simply just divide the numerator, divide the numerator by the denominator. So let's recall that we just take a quarter, 1/4. Remember, the top part is the numerator, and the bottom piece is the denominator, okay? So knowing this, we're going to now divide 4 into 1. So let's rewrite this as 4 into 1. So we know from the get-go, 4 cannot divide into 1. So I add a 0. And then I'm going to add a decimal point, knowing that I'm already past the whole numbers because 1 is a whole number. And if I try to divide it, I can't. So I have to add a 0 there. And then I also have to add a 0 next to the 1. So then I divide. Now I could divide 4 into 10 because 4 can get close to 10 2 times. And 4 times 8, 4 times 2 is 8, yeah. And I subtract, I borrow, 10 minus 8 is 2. I then continue, I add one more 0. I bring down this 0. 4 can go into 20 5 times. And that's my answer for that one. Let's do another example. 5, well, let's say negative 5 over 8. Now, before you flip out, when you see the negative sign, all you're going to do is this. You just write this as 8 over 5, and let me just erase this part here since we don't need that part. Just remember that 8 over 5 is really 8 divided into 5. So what I would do is to avoid the negative sign as your answer, just put the negative sign already in your quotient. So this way you avoid putting, let's say you did this, like that looks horrendous. It's awful. Like I don't even know what that even is, to be honest. It's just gross. Anyway, can 8 divide into 5? No. So we put a 0. Then we add a 0 to the 5. So it's 50 now. Can 8 divide into 50? Yes. 6 times 8 gives me 48. I subtract, I get 2. I add another 0. So now I have 20. Can 8 go into 20? Yes. 16. I subtract and I borrow. And I do this one more time. I get 40. Can 8 go into 40? Yes, 5 times. And that is your answer. So a good advice is to always remember when you're dividing, you need to know your times tables. You need to know them inside out. This way you don't have to worry about dividing or division. When it comes to division, you won't be worried about doing long division at all. Let's do some more problems like that. Let's say I had this example here. 2 over 3. Now this is an interesting one. What makes this one interesting? 3 tries to go into 2. It cannot, so I add a 0. I add a 0 here. Can 3 go into 20? Yes, 6 times. So I'm 18. I subtract, I borrow, I am left with 2. I do it again, I get the same thing. 6, 18, borrow, 2. Now, if you notice, there's a pattern going on here, because if I add one more 6, I know the devil. You bring down the 0, and I have 18, I subtract one more time, I'm get 2 again. So the rule about this is this. This is a repeating decimal. So let me write that down. A repeating decimal. So what do I do when the number repeats like this? What I'd recommend doing is this. You can go up to 3 times. You don't have to. I would say I would write a note here that would say note. If you noticed in your division a repeating number, then that will tell you to put a bar over the number, over the quotient, I should say, excuse me. Whoops, sorry. Over the quotient. Okay, so what does that mean? All I'm just telling you to do is, I know the number is going to be 0.6666666, so you put a bar over it, indicating that this decimal is going to repeat, so forth and so on. So remember that you got to be very careful when you see that situation happens. So let's do another example. Let's see if we have another example that's similar to that situation. Let's try 2 over 9. I divide 9 into 2. I add a 0, put that there, add a 0 at the bottom. In the dividend, 9 goes into 20 2 times, because 9 times 2 is 18, and here we go again. It's going to repeat. So to save time, you simply put the bar on top, because 2 right here appeared again here. So thus, that will tell you it's going to be a repeating decimal. When you notice that this 2, you start off with another 2, and so forth and so on, it's going to repeat. You can, again, if you want to test yourself, I recommend going max 3 digits. Why 3 digits? Because 1, you need to see whether or not the answer divides properly. 2, it repeats. Or 3, it's just going to go on forever and ever. And no offense, nobody has time, like nobody has infinite time that you can just keep dividing endlessly, because that's the only downside with irrational numbers. They tend to go on forever. Rational numbers, they tend to just, they're more convenient. It's in the name, rational, because they tend to just stop, and it's more convenient. One more example, why not? I'm feeling good today. I'm feeling generous. Let's do one more example. Let's try this one. 9 over 40. Now this is a little bit harder. 40, can it go into 9? It's too big, so now we have 90. 40 times 2 gives me 80. I get 10. I add another 0, 0. Can 40 go into 100? Yes, again, 80. Now you see what the difference with this one is. This one doesn't repeat, because you notice I start off with 9, but then I got 10. So that's why it didn't repeat. So here I'm going to get 20. I add one more 0. Then I bring down the 0 here. I'm left with 5, because 40 times 5 gives me 200. I subtract, I get 0. And that is my answer. So for homework, I'll give you guys one problem. Tell me what 5 over 6 is as your answer as a decimal. So you're going to write it as a decimal, okay? So that's the lesson for you guys. I hope you enjoyed it. Be sure to leave your answers down in the comment below. Mash that bell button and for more content. And if you have any questions, be sure to leave a comment down below. And also, this has been Absolute 5. Thank you for watching. I'm Roger Palomino. Math is infinite because there are infinitely many possibilities. And don't forget, don't hate, calculate.